Okay, so we're looking now at the hard trig equations that you're going to have to be able to solve. So we're looking at changing periods and phase shift. So we're looking at numbers in front of the pronumeral, like 2x or brackets. That's a phase shift. Okay, so start off with the first one. Cos 2x equals minus 1 on root 2. So the question will give you the domain. So the domain is this. Sorry about that. I'll just change to a pen. So that you've got to see in the question. And the first thing I do is I have 2x, I don't have 1x. So if I want to put 2x, that means I'm going to double x. So I'm going to double 0 and I'm going to double 2 pi. So even though x is between 0 and 2 pi, 2x is between 0 and 4 pi. So next step is looking at the quadrants. So we've still got our all stations to central. So cos is negative in the second and the third, but because I've got to go to 4 pi, 0, 2 pi, 4 pi, I've got to do another lap of the circle. So I just go to the second quadrant and add 4, and go to the third quadrant and add 7. Okay. Now, in the second quadrant, again, I've just put the little formulas, pi minus theta for second, pi plus theta for third. But when we get the sixth quadrant, we just go to the second quadrant answer and just add a circle, 2 pi. And for the seventh quadrant, we just go to the third quadrant answer and add a circle, 2 pi. So I didn't make it really clear, but the way I show it for solving equations is I always work out the answer in the first quadrant. So for instance, I just pretend that the number is a positive, and what I'm thinking of is this number, like some other, it doesn't have to be called another letter, but for instance, if I call it A, so cos A equals positive 1 on root 2, and so looking at the table of values, we get pi on 4, but we don't have a single letter, we have 2x. So we say whatever that number is in the bracket, or the circle, is 2x, and then you work out, okay, so theta is pi on 4 in that quadrant, but that's not the right quadrant, so we go pi minus a quarter, pi plus a quarter, and then to get these last two answers, we just add, okay, so we've got 4 as the denominator, so a circle, okay, so if you've got 2 pi and you want to put the denominator as 4, then just go 4 times 2 is 8. So I just got to add 8 and I get 11, and I add 8 and I got 13. But that's the answer to 2x, because we want the answer to x, then just divide through by 2. Okay, and so that last number there is your biggest number, and 13 pi on 8 is less than 2 pi, so you're back within the right range. So copy that, and when you're ready, come to the next slide. Okay, so the next one is one with brackets and a coefficient. Okay, so this is given to you in the question. So first thing we do is we double, okay, we double the x, and then what we do next is we subtract pi on 6 on both ends. So when you subtract pi on 6 from 0, you get a negative number, and negative just means instead of going that way, negative just means we're going that way. Okay, so that comes into it. And then when we subtract, hang on, just a minute, when we subtract pi on 6 from 4, okay, so just remember, if it's over 6, we multiply 6 by 4 is 24. So when I subtract 1, I get 23. Okay, so what we do is pretend that that's a positive a half. So in the first quadrant, for sine being a half, it's pi on 6. So for sine being a positive a half, not a negative a half, it's pi on 6. And so in the third quadrant, okay, I add pi on 6. For the fourth quadrant, I subtract pi on 6 from 2 pi. So that's my third quadrant, and that's my fourth quadrant. Okay, to get the seventh quadrant, go back to the third and add 12, because we've got a denominator of 6, we have to add 12. To get the eighth quadrant, go back to the fourth and add 12. And then this answer here we've got to take into account. So we've still got our all stations to central. So this quadrant here is called the negative first quadrant. Okay, that's why I put the negative first there, and the answer would be just minus pi on 6. Okay. Okay, so next step is add pi on 6 to all of them. So add 1 to all the numerators, because you've already got 6's. Now at this stage, you could cancel down the fractions, but I won't do. I'll do that at the end. So when you add pi on 6 to all of those numbers, you get all those numbers, and then I divide by 2, and I get all those numbers there, and then I cancel down at the last step. And you'll note that whenever you get an answer of 2 pi, you must have an answer of 0, because 0 and 2 pi are the same positions, but one's at the start of the lap and one's at the end of the lap. So just remember, if you ever get an answer of 2 pi, you should have an answer of 0 as well. Okay, so when we have this negative first quadrant, the answer might not exist, but we have to check it to see if it does exist. So copy that, and when you're ready, come across. Okay, so again, this one's not too hard. It just looks a little bit different. So first thing we do, first of all, you just always check. Okay, this time it's in degrees, so our answer is going to be degrees, not radians. So first thing you do is take the pi on 3 across, make it a negative, and then just divide by 3. Now that number doesn't look good, but it's the same as minus 1 on root 3. You just divide both numbers by root 3, and then that becomes one of your exact values. Okay? So we've got tan being negative, all stations 2 central, so tan is negative in second and fourth, but we've got to do 2 laps, okay? So it's going to be second, fourth, and then add 4, add 4. Okay, so tan is negative, but we pretend that it's a positive, so in the first quadrant it's 30 degrees, but that's not the right answer, but we need that number in our formulas. So we go 180 minus, 360 minus, and then add to get that answer to that answer, add 360, and then divide through by 2 to get those answers. And note that the last one is less than 360, which it had to be. If you get an answer that's bigger than 360, you're outside the domain, so your answer can't exist. Okay, copy that down. When you're ready, come to the next slide. Okay, next one is one that's a bit interesting. It ends up being a quadratic. Okay, so first thing we do is bring the cos theta across. Again, note the domain is back to radians, not degrees. So we've got 2 cos squared theta minus cos theta equals 0. Take out the common factor cos theta, leaving behind that. So that answer is 0, and this answer here is 2 cos theta minus 1 equals 0 to solve it. So 2 cos theta equals 1, so cos theta equals a half. So that's how I got that half value there. So you get 2 solutions. You get the 0 solution, and you get the half solution. Now this one here, 0. Okay, so cos is that line there. So the only way cos is 0 is in the middle, which means you're at pi on 2, or you're at 3 pi on 2. So these are called the boundaries. Boundary values. So the other boundary values are 1s and minus 1. So when you have 1s, minus 1s, or 0s, they're on the boundary. So you're looking at pi on 2s or pi's and things like that, depending if it's cos or sine. And for the second one, cos theta equals a half, straightforward. Again, all stations 2 central, so cos is positive in the first and fourth. You've got a first quadrant answer, pi on 3. You don't have to do any changes, and then subtract that from 2 pi to get the fourth. Okay, copy and come across. We've got 2 to go, or maybe 1. Okay, so this next one is the first one where sine and cos are in the same question. And this one here relies on the fact that in a unit circle, and I'll get some more colours. Okay, so that distance there is the radius, so that's 1. That distance there is sine theta, and that distance there is cos theta. And just using Pythagoras' theorem, sine squared theta plus cos squared theta equals 1 squared, so i.e. sine squared theta plus cos squared theta equals 1. So you can test it out. If you put sine squared 30 plus cos squared 30, you get 1. Or if you have sine squared 87 plus cos squared 87, you get 1. Okay, so this one here, when you've got coses and sines in the same question, you've got to use that sine squared plus cos squared equals 1 relationship, and you convert it to the one that's not squared. So that number there is what we're not going to change. Okay, so 3. Now, if cos squared is the subject, that means it must be 1 minus sine squared on the other side, minus sine theta minus 3 equals 0. Then expand out. Okay, just expand it out, and I don't like negative squared, so take everything to the other side. So take the 3, take everything across, so that becomes a plus. That becomes a plus, and 3 minus 3 is 0, so we've got 0 now. And then we've got sine theta is the common factor. 3 sine theta plus 1 equals 0. So that means that sine theta equals 0 for the first one. Or to solve that, you get minus 1/3. Okay, just had to leave the room to get a calculator. And so I've got a boundary value. So again, sine is going up and down. So for sine to be 0 in the middle, it must be 0. So it must be at 0 or pi or 2 pi. So sine theta equals 0 at 0, pi and 2 pi. And for this answer here, it's not going to be pretty. I didn't put that. Let's put some things here. I forgot to do that again. I'm going to go back to degrees. Bad. I should have done that at the start. And so for this one here, it's a few calculations to do. So we've got sine is negative. Okay, all stations to central. So with negative in the 3rd and 4th. In the first quadrant, the angle, we just go shift, sine 1/3 equals, so that's 19 degrees 28 minutes. And so in the third quadrant, we've got 180 plus, so 180, so 199.28 for the third, and for the fourth 360 minus that answer. And that gives us 340 degrees and 32 minutes. And you could test all your answers by plugging into the original equation, but they're the 4 answers, and I think that might be it. Yep. So that's our last slide on that one. So there'll be exercises to do probably off the worksheet. So thanks for coming.